Good morning. Today we will study homologous series. So first of all, what is homologous series? Just to compare your inorganic chemistry. In inorganic chemistry we have seen that elements are there in the periodic table. In particular group, the elements which are present, they are having the same properties. What is the reason? You have studied that they have the same valence electron. As in the inorganic chemistry, you have seen that elements in a particular group, they are having the same properties. In the same way, in the organic chemistry, the compounds, not the elements, the compounds which are having similar functional group or same functional group, their properties will be similar. So such compounds we are keeping together, the compounds which are having the similar properties, similar structure pattern, we keep together, and then when we keep all such compounds together, they will form homologous series. So what is homologous series? The organic compounds having similar properties, similar structure pattern are kept together, form a series called homologous series. The organic compounds having similar properties, similar structural patterns are kept together, form a series called homologous series. So this definition is given in the book, just you underline, page number 221. Series of organic compounds where the successive members follow a regular structural pattern and successive compound differing by CS2. So this is the definition. Next one is general characteristics. So what is the general characteristics? So first point here, examples of the homologous series. What are the examples of homologous series? Alkane. Alkane formula is CN H2n plus 2. Then alkene general formula is CnH2n. Then alkyne Cn H2n minus 2, and alcohol. Alcohol is Cn H2n plus 1. So these are the examples of the homologous series. Alkane CnH2n plus 2, then alkene CnH2n, alkyne CnH2n minus 2, alcohol CnH2n plus 1. What is the n? N is a number. N is a number. It can be 1, 2, 3, 4, any whole number, but it cannot be 0. So now next one is characteristics or general characteristics of homologous series. So the first point is given that all the members can be represented by same general formula. All the members can be represented by same general formula. Same general formula. This is the first characteristic, that all the members can be represented by same general formula. Then second point, two successive members differ by CH2 group are 14 AMU bonds. If you take the two members, the difference will be there, either CH2 group or 14 AMU bonds. Then third point, all the members are having chemical properties, all the members are having similar chemical properties because they have same functional group. In the coming topic, we will study what is functional group, and atom are a group of atom. Double or triple bond that define the characteristic property is called the functional group. In the organic chemistry, the organic compounds which are having the same functional group. For example, if you take CH3OH, methyl alcohol, ethyl alcohol. So this OH group is called the functional group. So these two compounds will have the same properties. In the same way, you have seen acetic acid, you write C double OH or SC double OH. So they are having same carboxylic groups, their properties will be same. So in the organic chemistry, the compounds which are having that same functional group, their properties will be same. Now, next one is that fourth point, all the members will have different physical properties. All the members will have different physical properties because they have different molecular mass. I want to tell you that physical properties that will depend on molecular mass. How it will depend on molecular mass? That you will study that intermolecular forces. But here van der Waals forces are there. So these van der Waals forces, van der Waals forces is directly proportional to molecular mass. Van der Waals forces directly proportional to molecular mass. It means when the molecular mass will increase, van der Waals force will increase. So for breaking the molecules, between the molecules force is there, more amount of energy will be required. So if the molecular mass is more, van der Waals force will be more. So their melting and boiling point will be high. So in the homologous series, when you move in homologous series from lower member to the higher members, their molecular mass will increase, van der Waals force will increase, so their melting and boiling point will increase. So that we will study. Now next one is that last point, all the members can be prepared by same general method of preparation. All the members can be prepared by same general method of preparation. So all the compounds they can be prepared by same method of preparation. So these are the characteristics. All the members can be represented by same formula. Two successive members differ by CH2 group or 14 AU mass. Then all the members are having the similar chemical properties because they have the same functional group, and all the members will have different physical properties because they have the different molecular mass, and all the members can be prepared by same general method of preparation. So now we will make the homologous series, and what characteristics we have studied. now we'll apply in the homologous series. So first of all, that we will take alkane homologous series. So what is the general formula of alkane? The general formula of alkane is CnH2n plus 2. So one by one we will make the homologous series, and whatever the characteristics we have studied, we will apply here. So first of all, alkane. Alkane general formula is CnH2n plus 2. Then here we will write molecular weight. So just to take N is equal to 1. So N is equal to 1, write C1. No need to write C1. And then 2, 1 is 2 plus 2, 4. So that will become CH2. Now N is equal to 2. Then C2. And 2 2s are 4 plus 2, 6. C2 is 6. Then N is equal to 3. Then C3. 3 to the 6 plus 2, 8. C3H8. Then N is equal to 4. C4. 4 to the 8 plus 2, 10. C4H10. Now you take the molecular mass. Then carbon 12 is there, hydrogen 1. Then 12 plus 4, 16 AMU, atomic mass. Then 12 to the 24 plus 6. 30 AMU. Then 12 3 then 36 plus 8, 44 AMU. Then 48 plus 10, 58 AMU. Now the name, how you will get this L will be same because this cyclic hydrocarbon is there, single bond is there, but L will change. So that I want to tell you, if carbon atom 1 is there, you are taking meth. If carbon atom 2 is there, H. If carbon atom 3 is there, you are taking pro. If carbon atom 4 is there, you are taking bu. If carbon atom 5 is there, you are taking pen. So what will happen? One carbon atom is there, so that is methane. Methane. 2 is there. Ethane, 3 is there, propane, then 4 is there, butane. Now take the difference as it is given that two successive numbers differ by CH2. So take the difference C2 minus C, only one C, S6 minus H4, CH2. Then C3 minus C2, C, then CH2. Then C4 minus C, S10 minus H2. Now take the difference of the molecular masses. So 30 minus 16, 14, 44 minus 30, 14, 58 minus 44, 14. So the difference is there, 14 AMU. So all the numbers can be represented by same general formula, first characteristic. So these are the numbers, they can be the same general formula. Then second characteristic we have studied that two successive numbers differ by CH2 group are 14 AMU mass, CH2 group are 14 AMU mass you are getting. Then we studied all the numbers will have the same chemical properties. So the numbers will have the same chemical properties here because all are saturated and with the carbon atom single bond is there. Then their physical properties will be different. So when you move down the series, just to see molecular mass is increasing, van der Waals force will increasing, so their melting and boiling point will increase. And all can be prepared by same method of preparation. So whatever the method of preparation of alkane is there, all member can be prepared. So this is the first homologous series, alkane. Now we take the alkene homologous series. So alkene homologous series, the general formula is CnH2n. So let us see alkene homologous series. So alkene, the general formula is CnH2n carbon-carbon double bond. So now the question for you, whether a single carbon atom can form a double bond? Your answer will be no, because minimum 2 carbon atoms are required. So that's why the first member of alkene homologous series, you will start from n is equal to 2, not n is equal to 1. So if you write n is equal to 2, then you will write here C2 and 2 to the 4, just double is it. In the same way, so 3, C3H6, n is equal to 4, C4H8. Like this, you can continue. And now just you see, the name of this compound, only L will change, E and E will be same. So for 2 carbon atom, you are taking F. So this one is ethene, this one is propene, this one is butene. Now take the molecular mass, then 12 to the 24 plus 4, 28 AMU. Here 12 to the 36 plus 6, 42 AMU, 48 plus 2, 50, 56 AMU. Then just to take the difference you will get CH2, 2 successive members, and if you take the difference of the molecular mass, 14, 14. Regarding the properties, chemical properties will be same because all are having the carbon-carbon double bond, all are unsaturated. Regarding the physical properties will increase because their molecular mass increases, so van der Waals force will also increase. So here the questions, very common questions that ask in board paper. What is the general formula of alkene? CNH2n. What is the first member of the alkene homologous series? So you will write the ethene, not methene. If you write in methene, you will be wrong. I told you that between the carbon atom at least one double bond is required. So the first number will start from n is equal to 2, not n is equal to 1. Now next one is that alkyne homologous series. So alkyne homologous series. Alkyne, the general formula of the alkyne is Cn H2n minus 2, and here you can write molecular weight. So here also it is compulsory that between 2 carbon atoms at least one triple bond is required. So here the first member will start from n is equal to 2, not n is equal to 1. Then you write C2, 2 to the 4 minus 2, C2H2. In the same way, n is equal to 3, C3, 3 to the 6 minus 2, 4, C3H4, n is equal to 4, C4, 4 to the 8 minus 2, C4H6. Then regarding the name of this one is only L will change. So this will be ethyne, propyne and butane. Now molecular mass you can take 12 to the 24, 28, then 12 to the 36 plus 4. This one is 12 to the 24 plus 2. This 26 will be there. Then 12 to the 36 plus 4, 40. 12 to the 48 plus 2, 50, 54. Now if you take the difference, you will get the difference of CH2 and then difference of molecular mass 14, 14. So the first member of alkyne homologous series, your answer is there, ethane. Now the last one, that alcohol homologous series. You can make the homologous series of alcohol also. So alcohol general formula is that Cn H2n plus 1 OH. this Cl H2n plus 1 OH. So here n is equal to 1, CH3 OH, n is equal to 2, C2H5 OH, n is equal to 3, C3H7 OH. Like this we will calculate the molecular mass. So here the first member, that CH3 OH. Now the questions for you, they will ask in board paper that find out the homologous series of the following compounds. So I am going to write the question here. So how to solve the problem? So the questions can be asked to you. Find out the homologous series of the following compounds. So C2H4, C2H6, C4H10, C2H2, C5H8. So C3H4, C3H7 OH. So these are the compounds. You have to find out the homologous series. So just to see how to solve this problem, alkane you have studied. Alkane is CnH2n plus 2, double plus 2 extra. Alkene is CnH2n, just double is there. Alkyne, CnH2n minus 2 and alcohol, CnH2n plus 1 OH. So in alkane, hydrogen atom is double and 2 extra. In alkene, hydrogen atom is double only. In alkyne, hydrogen atom is 2 less from the double, and alcohol you can recognize that OH. So now just to see, this one is C2H4 is written. This is just double. So double means alkene homologous series. So this is coming alkene. Then this one is double and 2 extra. So that one is alkane. This one is double and 2 extra, alkane. And this one is from the double 2 less is there, so alkyne. This one is 5 to the 10, 2 less is there, that is also alkyne. Then 3 to the 6, 2 less is there, alkyne. And this one is alcohol. So by this way you can do, and other method is there. Whatever the value of n is given to, you can write in all the formulas, then you can see which one is suitable. Now the next question asked in board paper, write the first member of alkene homologous series, first member of alkene homologous series, and first members of the alkyne homologous series. So the question for you, write the first members of alkane, alkene, and alkyne, homologous series. Write the first member of alkane, alkene, and alkyne. So for alkane, the first member is maintained, that is CH4. For alkene, the first member is ethene, that is C2H4. For alkyne, the first member is ethyne, that C2H2. If it is asked for alcohol, so the alcohol first member is CH3COH, that is methyl alcohol. Methyl alcohol. So this you can mark in your book, homologous series, important. And now we are going to stop this video, and in the next video we will discuss about the structure of organic